Good morning, guys. Today we're going to be starting a new topic. This is Notes 3.09. We're going to be looking at solving quadratic equations by factoring. And this is going to be part one of a section that we're going to look at. And then next class we're going to look at another aspect of this same kind of procedures. Okay. So again, quadratic equations, if you remember from the parent functions, quadratics are the graphs or the functions that have x squared. The equation has x squared in it, and the graph has like a U shape to it. Okay. And there's several methods that we're going to go through, but this lesson in particular will focus on factoring. Okay. So there's many methods to solve quadratic equations. So when you solve quadratic equations, the answers that you get are called solutions. Okay. So the first thing I want to go over is, what do you want to make sure you do when you're factoring? Okay. So to get your quadratic equation ready to factor, you got to move all the terms to one side. And remember, it's easier to factor if your leading coefficient is positive. So if the term that has the x squared is positive, then that'll make it a whole lot easier to factor. Okay? So let's look at example 1. And I'm gonna zoom in here just so I have space to write it out. Okay? So we're going to move all the terms to one side. So in this case, I have n squared and plus 2n on the left side. So if I have two items on the left, two terms on the left and one on the right, then it's easier for me to move the 8 to the other side. So how do you move values to the other side? Well, you have to do the opposite. So the opposite of a positive 8 is a negative 8. So we're going to subtract 8 on both sides. We subtract. So I'm going to get n squared plus 2n minus 8 equals to, what's 8 minus 8? That's 0. Okay. And so to factor, we've done factoring last semester, and there's different ways to factor, but in this case, I'm going to use the table method. Okay, so the table method, remember we're looking for two numbers that multiply, and remember there's a 1 in front of here, and we were looking for two numbers that multiply to give me, what's 1 times negative 8? It's negative 8. And then the middle number is 2, and so we want to find two numbers that add to give me 2. Okay? So if we think about possible numbers, we should end up coming up with 4. 4 times negative 2 is negative 8. And 4 plus negative 2 is 2. Extending that way this way. Okay. So these two check off, right? I get a negative 8 and a positive 2. So then I can factor this into 2 parentheses. And that gives me, so my answers would be n plus 4 and n minus 2. Okay. Okay, so the next part, example 2, I'm going to slide over. Sliding over to example 2. Again, we want to move everything to one side. I already have, 2 terms on the right here, and I have 1 term on the left. So it seems easier to move this one to the right. So let's do that. The opposite of -2 is +2. So these will cancel, giving me 0 equals, I'm going to put 2a squared first, then minus 12a, then positive 18. Okay. All right. So going back to the topics of when we factored, also remembering things like the GCF. And the reason I mention is because I believe all these numbers are divisible by 2. GCF is 2. So I can, divide all of these by 2. Bring down the 0. I get 2. Put the GCF in front. Divide everything by 2. 2 divided by 2 leaves you with a squared. -6 divided by 2, -12 divided by 2 gives you -6. And 18 divided by 2 gives you 9. Okay. Let me fix this negative here. And then we can use the table method, or you can see that it's a perfect square. But basically, like let's see, if I try the table method, I'm looking for 2 numbers that multiply to give me 9, and 2 numbers that add to give me -6. So you would come up with -3 times -3 gives me +9, and -3 plus -3 gives me -6. This gives me +9, right? So I get check marks here, and so I end up getting 0 equals 2. Then I'm going to put 2 parentheses. The letter they're using is A. And the numbers that worked were -3 times -3 gave me 9, and -3 plus -3 gave me -6. So I'm going to have a -3 here and a -3 here. Awesome. So this is just factoring. Okay, so let me zoom back out so we can see both examples here. So in these 2 examples, again, we were just practicing factoring. And we've done some factoring last semester, and so we're bringing it back. The only difference is that we're going to actually solve for answers of the variables. So we're going to solve for n, and we're going to solve for a. But here I just wanted to kind of show you, remind you guys the different processes that we can use for factoring. So the next thing I want to talk about is something called the zero product property. Product means multiplication. Make sure I'm zoomed in pretty good. Oh, sorry about that. All right, that looks good. All right, the zero product property says if the left side of an equation like this, where everything is on one side and on the other side there's a 0, can be factored, then the equation can be solved. So if you have something set up like this, and if you go back to example 1 and 2, that's how it was set up. It says if this can be factored, then the equation can be solved. Okay, using the property of zero product. Okay, so the property of zero product says if the product or multiplication, so let me substitute some words there. If the product, it means multiplication of two factors is 0, then at least one of the factors is 0. Okay. So it's just saying, right, if I tell you I'm going to multiply two numbers, A times B, and I'm telling you, oh, when I multiply these two numbers, my answer is 0. So then what can you assume about the two numbers that I multiply, right? If I didn't tell you anything about the numbers, you can assume that either the first number was 0, A was 0, or you can assume B was 0. Because I'm telling you that I multiplied two numbers and I got an answer of 0. And so the only way to get an answer of 0 is if one of the two numbers was 0. Or both of them are 0, right? Because 0 times 0 is also 0. So that's the zero product property. Okay. Now, let's see how we would use it in action. So let's look at example 3 and 4. And again, I'm going to zoom in just so that I have space to kind of work out and so you can see everything kind of clearly. I don't think I'm going to use all the space, but let's see. Okay, so then the zero product property, and I'm just going to write it again so I can write it a little bit, see it a little bit bigger. So the zero product property says that if I'm multiplying two things, let's call this A and B. If I'm multiplying two things, because there's multiplication happening right here in between the parentheses, if I'm multiplying and my answer is 0, that means that either this parentheses is 0 or this parentheses is 0. So we can assume that either x minus 3 is 0 or x plus 7 is 0. And what can we do now? We can solve for x. So let's solve for x. It's opposite of subtracting 3, adding 3. These will cancel. X equals 3. And the opposite of adding 7, subtract 7. 7 minus 7 will cancel, leaving you with x equals -7. All right. Now let's look at example 4. And again, I'm going to write it again so it's a little bit bigger. And again, we're using the zero product rule. So that means that either this part here is going to be my A, and this part here is my B, and they're multiplying, right? You're multiplying y times the parentheses. So if you're multiplying two things, the y and the parentheses, and you're getting an answer that's equal to 0, that means that either the first part is 0 or the second part is 0. So that means that either y is 0 or y minus 5 is 0. So this gives me one answer here. Then on the other side, I'm going to add 5, add 5. These will cancel. Y equals 5. So these are my two solutions. All right, so let me zoom out again so we can see both examples. Awesome. So using the zero product property helps us to find the values of x. So we found, or the values of the variable. In this case, the variable is x. In this case, the variable is y. All right. The next page kind of gives you some steps to think about when factoring. So when solving a quadratic equation, use the following steps. Get your quadratic equation ready to factor by moving all the terms to one side. So that's what we practiced in examples 1 and 2. And then factor the quadratic equation using, first remember to look for the GCF, and then we can use one of the methods that we practiced last semester. Remember, we used a table method, we had a perfect square trinomial, and then we had a difference of squares. So using one of these things from last semester. So again, step 2 is from last semester. And then the third step, use the zero product property to find all the possible values of x. A side note, the solutions to a quadratic equation are called roots. All right. So let's look at the examples. Let's look at the instructions, right? For examples 5 through 8. For examples 5 through 8, find all the possible roots for the quadratic equations. Find all the possible roots. So remember, roots, when they use the word roots, this means solutions. Okay? So let's look at example 5. And again, I'm just going to zoom in so we have enough space to work. Okay, so here, is there a GCF? If I'm looking for a GCF, to start off with, I think the GCF is 1, right? Because they both don't have x's, and you can divide both of them by 1. The other question is this a perfect square trinomial? Is this a table method situation, or is this a difference of squares? And to me, it looks like a difference of squares. Because remember, for the difference of squares, we wanted to check, if I square root the first term and the last term, do I get an answer, right? So I get x and I get 9. So yes, I can square root the first term and the last term. The other thing that we want to check is there a subtraction, right? Because for a difference of squares, there would be subtraction. And if we remember about difference of squares, we would say, this is our A, this is our B, and we would set up something like, A plus B and A times A minus B. So we're going to do that with, just going to rewrite it again. Over here, x squared minus 81 equals 0. Then we can write it as 2 parentheses, equals 0. And it's going to be x plus 9 and x minus 9. And then we would use the 0 property. And I'm going to use a different color here because I don't want to use the same colors Yeah, I'm gonna use this one. Okay, so if this is A and this section is B, right, then we're saying that if I'm multiplying two things and it equals to 0, that can either mean that x plus 9 equals 0, or it could mean that x minus 9 equals 0. So I would solve for x, minus 9, cancel, x equals negative 9, and then plus 9, these cancel, x equals 9. Right, so my two solutions are 9. And of course we can check them, right? What's 9, or we can check it over here. What's 9 times 9? 81. What's 81 minus 81? That'll give me 0. Same thing with negative 9. What's negative 9 times negative 9? That's 81. 81 minus 81, that also equals 0. So we got two answers for x. Right. Let me slide over to example 6. Right, so let's go to step 1. Let's see, what did step 1 say again? If you go up here, get your quadratic equation ready to factor by moving all the terms to one side. Okay, so we're going to move all the terms to one side. Let me slide back over to example 6. So I'm going to move the 4m to the left. So I'm going to do that by subtracting 4m on both sides. On the left side, I get m squared minus 4m equals 0. And then I can check to see, do I have a GCF? And you should see that both of them have an m, right? Both terms have an m. So I can divide by that m. And so I'm going to put the m in front, put parentheses, equals 0. M squared divided by m is m. M divided by m cancels. Right? M squared divided by m is m. 4m divided by m is just negative 4. So then we have this situation again of the a times b. So, oh, sorry. I'm just getting my colors ready. So this is my a, and this is my b. So if I multiply them and I'm getting 0, that either means that either m equals 0 or m minus 4 equals 0. And so this gives me one answer. And here I would have to add 4 on both sides. These cancel, and I get m equals 4 as my second answer. Okay. And just as a reminder, right, you can also call these answers roots. So I can write a sentence and say, my roots are 0 and 4. So the two answers that I got, you can call them solutions, you can call them roots, you can call them zeros. All right, let's go over to example 7. And so step 1 is to move everything to one side. and I already have 2 terms over here, and I have 1 term over here. So instead of me moving two items to the left, I can just move this 1 item to the right. And I also want the squared term to be positive, so I can do 2 things at once, right? I can get what I want in 1 move. So I'm going to add a squared on both sides. It's going to cancel here, and it's going to give me 0 equals, well, I'm going to show you what I usually like to do. Right, I'm going to get 9 minus 6a plus a squared, but I like to write this with the a squared first, and then the a term, and then the number by itself. So I'm going to rewrite this the way I like to write it. This is called standard form, actually. Standard form just means you write the term with the largest exponent first, then the second largest exponent, and then the constant is last. Okay. So we can try and factor this. We can try and use the table method. We can ask ourselves, is this a difference of squares, perfect square trinomial? It isn't a difference of squares, right? Because a difference of squares should only have 2 terms. So it could be a perfect square trinomial. But again, we have to check, right? Can I square root? Actually, let me write it. Where do I want to write it? Yeah, let me write it over here. Can I square root the first term? Yes. Can I square root the last term? Yes. And then, if you remember this part, you know, if this is my A and my B, I want to check to see what is 2 times A times B the middle term. So let's see. What is 2 times A times B? Right, because this is A, this is B. 2 times A is 2A. 2A times 3 is 6A. Do they match? Yes. So then we have a perfect square trinomial. So that means that if it has a minus in the middle, then we have, it's going to be A minus B times A minus B. Right, this is my A, this is my B. So I'm going to rewrite it. I have 0 equals, and I'm going to rewrite it down here. And so it's going to be parentheses A minus 3, A minus 3. All right. So then we're going to check and see. The next thing is the 0 property. Right, if this is A times B, or if I'm multiplying these two, yeah, let me just write it that way. I don't want to keep writing A and B and A and B. Okay, so if I look at these two parts that I kind of underlined with a squiggly bracket, then we can use the 0 property, right? If these are multiplying and I'm getting an answer of 0, that means that either A minus 3 is 0 or a minus 3 is 0. So we're getting the same conclusion, right? So we just have to solve for 1. So I'll just solve for this one. Plus 3. I get a equals 3. Of course, these cancel. So I get one solution here, because if I solve this one, I'll also get a equals 3. So this is my solution. Okay. Let's go to the last example, example 8. Okay, move everything to one side. That's the first rule. So I also want to get, if I look at the n squares, I want to get a positive n squared. So I'm actually going to move the 4n squared first. So if I subtract 4n squared on both sides, I will get 5 minus 4 is just n squared. I'm going to bring down the minus 20 equals, these will cancel. I get 9n plus 16. Then I can subtract 9n, and that gives me n squared minus 9n minus 20 equals, these will cancel, equals 16, and then subtract 16, that gives me n squared minus 9n minus 36 equals 0. Alright, so we should be able to see that we can possibly use the table method. Okay, because of course it's not a difference of squares, it's not made up of two terms. The last term is negative. If it has three terms and the last term is negative, then it's for sure not a perfect square trinomial. So the only other method is the table method. And so the table method, you know, if there's a 1 in front here, if I multiply these two numbers, I get negative 36, and then the middle number is what I want to add, so to get 9. And so what numbers can you think of to multiply to get negative 36 and add to get negative 9? And what should come to mind is negative 12 and positive 3. Because multiplying these two would give me negative 36. And if I add them, negative 12 plus 3 gives me negative 9. So this checks off. Right. So I'm going to rewrite this equation. I wanted to make an arrow there, but it didn't look like I wanted it to. Okay, so we're going to make the equation, you know, made up of two parentheses equals 0. And so the numbers that worked were negative 12 and 3. So the variable is n, so I'm going to put n in both parentheses, and I'm going to put minus 12 and positive 3. All right, well that means that I have two parts here. And so if I'm multiplying this purple part and this green part, and it's equaling to 0, that means that either n minus 12 equals 0, or n plus 3 equals 0. And so if I solve it, if I add 12 on both sides over here, these will cancel. I get n equals 12 as one answer. And then on the other one, I'm subtracting 3. These cancel. And I get n equals negative 3 on the other side. And so these are my two solutions. These are my two answers. That brings us to the end of our notes. And so again, guys, if you have any questions, I can go over those during class. Again, thank you for watching, and I'll see you guys next time.